this lesson, we're going to talk about representing relations and just the different ways that we can represent them, some basic vocabulary. Hopefully, a lot of it will be review. And so let's just get started with what is a relation. So a relation is a set of ordered pairs. And we'll use curly brackets to group the ordered pairs together. So let's take a look at an example. So here's an example of a relation. So we have this relation as a set of these ordered pairs. Each ordered pair is grouped individually by parentheses. So an ordered pair is an x and a y that make a point that we could potentially graph on the coordinate grid. And so we'll separate each ordered pair by commas and group the entire relation with curly brackets. Okay, we want to start by listing the domain. Remember that your domain is made up of your x values. So I'll remember domain and x because if I were to draw a line or write the word domain and x on the same line, none of the letters would drop below the line. So that's how I remember domain is x, whereas if I were to draw or write the word range on a line, you can see that the G dips below and the Y dips below. So it's a silly little way, but for me it works in remembering that range is my Y values, domain is my X values. So looking at the domain here, the X values are made up of 1, 1, and 2. When we are listing a domain, we will not repeat values that come up more than once. We'll just write them one time. Now, because a domain is a set of values, we're going to write that set of values with curly brackets under it. I want you to notice, though, that there are no parentheses inside anymore because we're just listing each x value. They're not points anymore. It's just the x's of the points. So for the domain, we use curly brackets and list all the x's. For the range, we'll list all the y's. So 6, 7, and 7. And we see that the 7's repeat, so we only write that one time as well. Okay. The inverse of a relation, this might be a new vocabulary word, can be found by switching the x and y values. So if this is our relation, then I could find the inverse by, in a sense, flipping the y and the x values with each other. So whatever was my y is now my x, and whatever was my x now becomes my y. And doing that for each point would give me the inverse of this relation as 6, 1, 7, 1, and 7, 2. So flipping the x and y values each time. So this year our goal is just to define what an inverse is, be able to find an inverse from a set. And we're going to then do an activity after this lesson in class where we'll explore how a relation and its inverse look on the coordinate grid compared to each other. But that's as far as we're really going to go with inverses this year. But you are expected to know how to write an inverse from a relation. So we'll do that by flipping the x and y values with each other. With a relation, we're going to have 3 ways of representing relations. Several of these hopefully you've seen. Maybe the map will be a new one, but we'll be able to represent a relation. It's just a set of data as either a chart, a map, or a graph. So let's start with a chart, which you might know more commonly as a table, which it's not letting me write, but okay. Oh, that looks terrible. Anyways, a chart and a table are the same thing. Okay, so it's a way of showing ordered pairs in a table with x and y coordinates. So you'll see I can set up my table, I label the columns x and y, x is always first, and then I list the points. So I list my x's and then their corresponding y's. The y's that go with those x's are listed in order. So I should be able to read across and see the point -2, -4 is an ordered pair in my relation, and it's just written so that they match up along the row together. Okay, so we do that with all of our points. In a table, if we were to have an input repeat, we would, let's say I had another point that was 2, 5, I would write that again, I would write another 2 as an x and then the output 5 again. So this is going to be the slight difference between a table and a map, which we'll look at next. So a map is similar to a table in that we list the x's, list the y's, but instead of grid lines, we will connect the x value with its y value with an arrow. So we're showing that 2 is the x, or the input, and -2, and so its output is -4, meaning that creates the point -2, -4. Okay, we then have the point -1, -2, 0, 0, 1, 2, and 2, 4. So when we draw a map, we circle the x's and circle the y's and connect the x's with their y's using arrows. Using maps is really helpful for situations where we have repeated x and y values. So let's come back to this relation. So if I use this one, let's put it right here. Okay. If I'm using this relation, you'll notice the 1's repeat and the 7's repeat. So using a map can be really helpful because when we're mapping, we actually don't write values that repeat more than once. So there's several 1's, but I'm only going to write it once as my x values. So I'll circle those. And then for my y's, I do not write the 7 more than once either. I just write that 7 one time. So for the y's, I have 6 and 7. And so the nice thing about mapping is if my 1 maps to a 6, I connect them. But if my 1 also maps to a 7, I can show that with another arrow. And then my 2 maps to the 7. So it's a nice way, if lots of values repeat, to kind of consolidate all of our data and get it written and mapped out that way. The last way we'll represent a relation is by graphing. So it's a way of showing our ordered pairs for an equation by plotting each point in a graph. So here our points are -1, -2, 0, 0, 1, 2, and 2, 4. And those, I guess, were the points that we had in the relation, then we plotted them all. So a graph you have seen many times. You just plot your coordinates and get them on the graph. And that's how we'll show a relation using a graph. All right, so let's practice now. Here you're given a relation. I want you to create your own chart or table, map, and graph using this data. So at this time, pause the video and then pick back up once you've created your table, map, and graph. Okay, so you've created your table, and it should look like a column of x's and a column of y's. Notice my 2's repeat as x values, so they showed up 2 times as x values here, so that I have the row corresponding with its output, and that is how it should be written. With our map, we should have only written that 2 that repeated 1 time as an x value and connected the 2 with its 2 different outputs. Okay, make sure you're circling your x's, circling the y's, and labeling those up top. And then a quick sketch of the graph. You hopefully will have some tick marks here. 2, 3, 4, 5, and so on. So there we're just plotting the points. Okay. And lastly, let's practice writing the inverse of this relation. So pause the video, write the inverse. Okay, so we should have gotten 3, 2, -1, 4, 5, 2, and 1, -3 as the inverse relation. Notice I have curly brackets. Notice I'm using parentheses for each of the ordered pairs. And lastly, let's state the domain of this inverse. So using the inverse now, list the domain and range. Oops. So our domain is made up of 3, -1, 5, and 1. And our range is made up of 2, 4, 2 again, so we only write it once, and -3. And that concludes the lesson for today of just some basic vocabulary that we'll be using this unit.